Hi guys, welcome back to my channel. In this video, we're discussing the different features of relative position and we will start with the z-score. Without further ado, let's get this lesson started. Z-score is otherwise known as the standard score. It is called the standard score because it compares the data value and the mean with respect to its standard deviation. So it's as if we are standardizing the data value. So we can use the following formula depending upon if we are given with the population or the sample. If we are given with the population, we will use this formula. Z sub x is the z-score. X is the score itself, the ordinary or the given score. Mu here is the population mean. And of course, we have the population standard deviation. So basically, we will just subtract the score and the mean divided by the standard deviation. That is the same when we have sample. The only thing that will be different are the notation for the mean, which is now x bar because we are dealing with sample, and of course, small letter s for the sample standard deviation. So to better understand how we will interpret this z-score, so we will look at its value. If it is positive, then the data value is higher than the mean. Or if it is negative, then the data value is less than the mean. Also, there are cases wherein we will get the absolute value of that z-score. We will look at the number itself. So the higher the z-score, the more ideal the situation is because a higher z-score means there is a better performance of a certain person or a certain thing that we are testing. So let's have this example. For instance, Justin has taken 2 quizzes in his mathematics class. He scored 72 on the first quiz, and that first quiz has a mean of all the scores with 65, and the standard deviation is 8. As for the second quiz, his score is 60, but the mean of those scores are 45, and the standard deviation was 12. So, in comparison to other students, did Justin do better on the first or on the second quiz? So, what we are going to do with this is we will identify the standing of Justin as compared to other students. Where did he perform better? Is it on the first quiz or on the second quiz? So, since we are dealing with comparison with other students, it gives us a clue that we are solving for the relative position. How far or what is the standing of Justin's score as compared to the score of his classmates for the first and the second quiz. And then afterwards, we will compare. So for the first quiz, we have his score as 72, the mean is 65, and the standard deviation was 8. So we will just recall the formula for the z-score. We have the score minus mean over standard deviation. So the score here is 72. We subtract it with 65, and then the standard deviation is 8. So, computing, we have 72 minus 65. It will result to 7, and then divide it by 8. Afterwards, we will round off the quotient into the nearest hundreds. So, meaning our quotient is 0.875 or 0.88. So for the first quiz, this is the z-score of Justin. Let's solve for the z-score for the second quiz. So for this one, we have his score as 60. The mean is 45 and the standard deviation was 12. At first glance, you may notice that quiz 2 has a smaller mean as compared to quiz 1. And his score for quiz 2 is, of course, smaller than quiz 1. So later, after we have solved the standard score for quiz 2, we will compare to know where did Justin perform better. So I suggest you do it on your own. Pause this video for a while and solve for Justin's score for quiz 2. Afterwards, we will resume the video to know if your answer is correct. So we have here z sub x. We have here x minus mean over the standard deviation. We have here 60 minus 45 over 12. 60 minus 45, that will result to 15. Divided by 12, it will result to 1.25. So z sub x is 1.25. So comparing these two z-scores, we can say that the z-score of quiz 1 is less than the z-score of quiz 2. So this is what I was telling a while ago. The larger the number for the z-score, it means that the better the performance. So comparing the two z-scores, we can see that the z-score for the second quiz is higher. It means that the score of Justin for quiz 2 is 1.25 standard deviations away from the mean. This is relatively higher as compared to 0.88, that only means 0.88 standard deviations away from the mean. So we can really see that if this is the mean score and this is Justin's score, their difference is 1.25 units of standard deviation. As compared to this scenario, we have here the mean and then this is his score. Their difference is 0.88 units of SD or of standard deviation. So we can see here the difference of the scores of Justin from the mean, and we can say that his score for quiz 2 is farther from the mean, higher from the mean. That's why we can say that in comparison to other students, he performed better on the second quiz than on the first quiz. Next, we go to example 2. Say for example, we have a consumer group that tested a sample of 100 light bulbs and found that the mean life expectancy of light bulbs was 842 hours. This life expectancy of light bulbs means how long or the number of hours that light bulb will work. So, and the mean of those hours was 842. And its standard deviation is 90. So, a particular light bulb from a certain company, Sparks Bright, has a z-score of 1.2. So, what is the exact lifespan of this light bulb? So, we list down the given first. So, of course, we have here the mean, which is 842 hours. Standard deviation is 90, and we have here the z-score as 1.2. So we are actually looking for the exact lifespan, which is x score or the original score. So what we're going to do is we will work backwards. Say for instance, we have this formula for the z-score. And then we will manipulate this formula in order to arrive with the value of x, because that is what we are to solve. So we have here 1.2 as the z-score. X is the unknown. And the standard deviation is 90. So we will solve for x. First, we multiply the entire equation by 90. This will be 1.2 times 90. As for the right side, 90 will be eliminated, leaving us with x minus 840. Multiply these two numbers, we will have 108 x minus 840. And finally, we will transpose negative 842 on the other side, making it look like this. We have 108 plus 842 equals x. Adding the two numbers on the left side, we will arrive with 950. So that is the lifespan of the light bulb from Sparks Bright. Therefore, that light bulb has a lifespan of 950 hours. So that's it on how we solve and interpret z-scores. Again, this z-score is a measure of relative position. It talks about the number of standard deviation a certain data is away from the mean. In the next video, we will be dealing with another measure of position. Thank you for watching and see you on the next video.